wasn't always like this. We weren't always known for engineering. We didn't have a medical school, let alone two. And there were no PhD programs, Fulbright scholars, or thriving college town. It's easy to take it all for granted because a lot of us have never known it any other way. But just a few years ago, this was a very different institution. A well-regarded local state college that served the public without fanfare, ready to stay the course. Until one gift, a $100 million transformational gift, changed everything and set Glassboro State on the path to become Rowan University. And since then, we started one of the top 25 undergraduate engineering programs in the nation, fostered entrepreneurial spirits in our business programs, cultivated ambition, excellence, and broader horizons throughout the curricula, and responded to the national need for 21st century healthcare with innovative health sciences and medical education. In our colleges, schools, centers, and institutes, we're conducting world-class research that's meeting society's needs and solving the problems of business and industry. We're the fourth fastest growing research institution in the nation, a top 100 national public research university dedicated to excellent undergraduate education. We're providing more scholarships, increasing access to college education, and reducing the financial burden of earning a valuable 4-year degree. We're nationally ranked and routinely earn national notice for students and faculty doing extraordinary things. We're driving the economy of the region and increasing what New Jersey can do to help its citizens be healthier, more productive, and secure. Transformation is not just the story of Rowan University, it's the promise offered to everyone who walks through our doors. Students find themselves and a foundation for their future. Researchers devote themselves to discovery and understanding. Innovators, scholars, entrepreneurs, everyone with curiosity and commitment to know more and do more, they all transform our world. So when it seems like Rowan University is continually forging new pathways, it's because it's true. We're creating new ways to learn, explore, and build. We're partnering with business and industry, educators and leaders to accomplish more together. We're encouraging people to imagine, equipping them to pursue and achieve. Being transformed is more than Rowan's story. It's the future we share with New Jersey and our region. Here's to decades more discovery, growth, and transformation at Rowan University.
Hello, and welcome to all of our prospective students and their families. I'm Dr. Stephanie Farrell, Interim Dean of the Henry M. Rowan College of Engineering, and I want to thank you for attending today's virtual open house. We have an exciting program planned for you today that will include a virtual tour of our facilities, a live presentation by our department heads, demonstrations by our students, and a live question and answer session. If you have questions, please type them in the comments section and we will answer them toward the end of the program. Rowan Engineering has student-centered, hands-on, project-based programs. Lab-based courses are integrated into most of our curriculum and our unique engineering clinic course sequence. Here, students have the opportunity to work collaboratively with faculty and industry professionals, along with their fellow students, to solve real-world problems. And you'll get to be part of groundbreaking discoveries. Working on these projects often leads to summer internships, presentations at national conferences, and even publishing opportunities. At Rowan, you'll be part of an undergraduate experience that has been recognized nationally. Our outstanding students and faculty have catapulted us to a U.S. News & World Report ranking of number 17 in the nation for undergraduate engineering education. And importantly, our program is one of the most affordable engineering degrees you will find. Both our retention rate and our graduation rate exceed national averages by over 20%, and we routinely place more than 90% of our graduates in jobs in industry or in graduate school. Finally, being a Rowan engineer is not just about being in the classroom or the lab. We have a variety of student clubs and professional organizations which offer students a chance to get involved, build a network, and develop professional skills. This is an exciting time to be at Rowan, one of the nation's fastest growing universities, and to join the ranks of thousands of successful Rowan engineering graduates who are solving the problems of the 21st century. Welcome to Rowan Engineering.
The Henry M. Rowan College of Engineering is one of 12 colleges and schools that make up Rowan University. Proudly, U.S. News & World Report has ranked our college 17th in the nation in our peer group and has recognized our university as one of the top 100 public universities in the nation. Our program is anchored by the unique and distinctive Engineering Clinic. This signature curriculum structures an 8-semester sequence that ensures our students are exposed to real-world, industry, government agency, and private foundation-sponsored engineering challenges. Our curriculum successfully prepares students for both engineering careers and advanced graduate study. Students work in interdisciplinary teams to meet project goals and deliverables, work directly with faculty, and network with leading industry professionals. In many instances, students are able to secure internships and full-time employment offers through working in engineering clinics. The Department of Civil and Environmental Engineering is a leader in developing solutions for a world that is rapidly changing. From structures to transportation systems, resiliency, and environmental protection, our department has extensive expertise. Companies and agencies such as AECOM, American Asphalt, the Army Corps of Engineers, Atlantic City Electric, Gannett Fleming, and the Department of Transportation have sponsored our program and recruited our graduates. Our nationally ranked electrical and computer engineering program is one of few throughout the nation that meet accreditation requirements for both electrical engineering and computer engineering, giving our students a competitive advantage in the workplace. Notable clinic projects from the department are sponsored by Lockheed Martin, NASA, the FAA, and the United States Navy. As we grew in size and enrollment, we doubled the number of our full-time faculty, ensuring that the small class sizes and low student-to-faculty ratio, which has long been a hallmark of our programs, remains intact. At Rowan, you will not simply be one of hundreds of faces in a lecture hall. You will have an opportunity to work directly with faculty in small class settings conducive to student success. Biomedical engineering sits at the nexus of engineering and healthcare. Integrated with Rowan's 2 medical schools, our program is one of the fastest growing in the nation. Rowan students lead projects funded by NSF, NIH, and major biotechnology companies. Students have a strong record of placement in top graduate schools and careers with Merck, Stryker, Johnson & Johnson, Bristol Myers Squibb, Medtronic, and others. Our college has recently seen unprecedented levels of growth, including bringing online a full state-of-the-art academic building, Engineering Hall, a full-scale renovation of our original home, Rowan Hall, ensuring all of our academic departments and students are able to benefit from modern, dedicated teaching and research spaces. The college's chemical engineering department has extensive expertise and a learning environment that replicates industry standards. From our multi-story distillation tower to our cold spray labs, Rowan chemical engineers graduate with hands-on experience. Rowan students have been able to work on projects sponsored by ExxonMobil, General Mills, Johnson Matthey, and the EPA, among a range of other agencies and companies. The college supports 4 major research centers: advanced manufacturing and materials, virtual and augmented reality, sustainable facilities, and transportation. Many institutions often reserve research center collaboration opportunities for graduate students, but at Rowan, undergraduates are welcome contributors to our thriving $50 million research operation. Our experiential engineering education department is home to the innovative engineering entrepreneurship degree and common first and second year engineering courses. The department leads the college's educational research program, ensuring Rowan students have the opportunity to directly benefit from groundbreaking discoveries. Rowan's nationally ranked mechanical engineering program is one of the most academically competitive departments in the state of New Jersey. Our graduates have recently pioneered advances in the aviation industry and in automated vehicle systems, among a broad range of other sectors. Along with students in ECE, select students might also be able to join an exclusive 4-year co-op program with Lockheed Martin. The college is also one of the largest tenants of the South Jersey Tech Park of Rowan University. Located just 1 mile from the Glassboro campus, this center houses several research centers and labs and offers opportunities for private sector businesses, small startup companies, and university faculty and students to collaborate and innovate. The diverse range of student-run extracurricular activities also affords students with opportunities to apply what they've learned in the classroom, form relationship with their peers and students from across the college and university, all while tackling exciting challenges and service opportunities. This is the Henry M. Rowan College of Engineering at Rowan University.
Go, Mark. Welcome to Rowan Biomedical Engineering. My name is Dr. Mark Byrne. I'm the founding department head and professor. And joining me is Dr. Mary Staley. She is the undergraduate program chair and a professor in the department. So thank you so much for joining us this morning. We're going to talk briefly, but more importantly, we are going to share some of our best and brightest with you, and that's our students. And they're going to talk about their projects, as well as be available to answer any questions you may have. So feel free, enter those questions in your chat, and we'll get to them at the end of this session, okay? So our department, you just saw that video, and what's most important here is we are one of the fastest growing departments in the country. We're also one of the departments that are really pressing to be the top department in the country, and this is due to a few things. We're building an impressive culture here, and it all revolves around passionate, bright, top faculty in their field that educate our students. And those faculty, we want them to do 3 things well. 1, have a cutting-edge research program, so they go out, they find money, they get money from NIH, NSF, some of the biggest, most prestigious organizations throughout the country, and they use that to fund cutting-edge work in the area of biomedical engineering. So they just don't teach, but they do. Second, they bring passion to the classroom. They teach using innovative methods, and we've really designed a curriculum that touches on a number of great points that lead to an excellent education. And lastly, what we have in this department is an individualized, personalized experience that every student has what they need to get where they want to go, whether it's a top industry job or whether it's a top position at graduate school or professional school. So without further ado, Dr. Staley will highlight some of our curriculum elements and tell you a little bit more about our students.
Great, thank you, Dr. Byrne. So I wanted to mention, first of all, that we're exceptionally proud of our students, and each of them receives an individualized experience here and receives mentoring both at an academic progression as well as through their professional aspirations. And our students have achieved some of the top awards throughout the country, some of the most prestigious awards that are offered. And in the short history of our department leads the university in those prestigious opportunities. We have in prestigious scholarships that our students have been awarded. So we're very proud of them. And we're also really proud of the curriculum that we've put together that have trained these students to become those leading applicants around the country to obtain those awards. Our students participate in a hands-on, minds-on curriculum that spans across the 4 years of our curriculum. And it's highlighted by both breadth and depth in biomedical engineering, and I invite you to visit our website to see some of the course offerings that we have and the way that we achieve those breadth and depth, and also to ask any questions that you may have about our courses, and the students can talk about them in a little bit, in just a few minutes. But I do want to highlight that the Rowan Engineering experience is highlighted by, and the hallmark of Rowan Engineering is our engineering clinic sequence, and you'll hear our students talk about their clinic projects. It's a little misleading in the area of biomedical engineering, but here clinic means hands-on work on real problems. So our students are engaged in real problem solving, in real problems, and that experience ranges throughout the entire 4 years of their experience here in Rowan Engineering. So we can talk a little bit more about the depth and breadth and the areas of concentration that the students have as we move through the program today. But we thank you for joining us, and I'd like to, at this point, turn it over to introduce you to our first student. So the first student that we have that will talk about their work today, will be talking about her work in engineering clinic. And Lucinda, I think you're up first.
Thank you, Dr. Staley, for introducing me.
So Lucinda, tell us about your project. You're obviously doing something with innovative cannulas.
Yeah, so my clinic project is actually in collaboration with Dr. Jeffrey Joseph at Thomas Jefferson University, and is also funded by this biomedical device company called Capillary Biomedical. And just for a little background on my actual clinic project, the majority of people who use insulin pumps are type 1 diabetics, and the problem with insulin pumps right now is that you have to essentially change the infusion site every day, or at least every 2 to 3 days. So as you can imagine, that can get really annoying to have to do this daily, and you actually get a lot of scars around your lower abdomen. So with our aim and this project, we're trying to create a hydrogel coating that has anti-inflammatory drugs to decrease this body's attack response to the catheters, and our aim is to increase that implantation time to about a month.
Okay, so essentially less side effects due to catheter use. You're going to deliver this drug that's going to limit inflammation for an extended period of time.
Yeah, exactly. And the benefit to this is that without the anti-inflammatory drugs, the body actually creates scar tissue around that implantation site, and that not only decreases the efficacy of the actual pump because the insulin's not being absorbed by the body as efficiently, but it also is painful because of that inflammation that occurs there. So by using anti-inflammatory drugs, we're getting rid of that completely.
It's great, thank you. So Lucinda is one of our 3+4 students. So that means that she's a senior and she's completing her BS degree in 3 years, and then she seamlessly enters our medical school, our Cooper Medical School of Rowan University. So 3 years finishing your degree, that must be difficult. Can you tell us a little bit about that?
Well, I came into Rowan with a lot of credits in high school. I took classes at my local community college, which was really helpful. I also had some AP credits, although not as many because I went to a high school that was very small, so they didn't offer as many credits. But I know I probably came in with the least amount of credits, but I still managed. Like my class load wasn't horrible. Like the classes, like I could catch up really easily. So I think that was great. Yeah.
That's great. Well, you know what? I appreciate you joining us today. One of the benchmarks of Rowan Engineering is we find a way to do things in slightly different ways. And I can tell you, the program that Lucinda's in, it really focuses on the student of doing as well as they can, learning the fundamentals, but also being exposed to our medical school and great projects like this. So thank you so much, Lucinda. Thank you.
Thank you, Dr. Byrne.
All right, so next is Antonio. Antonio, why don't you come on up? So Antonio's project dealt with an issue which is helping radiologists discover and detect cancer. So Antonio, thank you for joining us.
Hi everyone. So the name of my project is the classification of lung tumor in convolutional neural networks, which is basically a type of artificial intelligence. This project is in collaboration with Oncopathogenomics, a company based out of Robert Wood Johnson Medical School in Rutgers, New Jersey. And we've been working with different CT images that we get from, as you can see here. As of now, they're the current gold standard for identifying lung cancer. Radiologists will look at these CT images and decide whether or not a nodule is cancerous or not. The problem with that, however, is they can't make a definitive diagnosis without doing an actual biopsy. So biopsies are costly and invasive, and we're mainly trying to reduce that need for that. There's a very high false positive rate as well, so a lot of times they're not needed in the first place. Lung cancer is actually the disease with the highest mortality rate among all cancers. So the problem is it's not being able to be diagnosed early, which leads to this high mortality rate. So we have developed this artificial intelligence program where different CT images are sent through the model, and it's able to produce an output of benign or malignant. So the CT images are actually pixelized and sent through this pre-processing model where they're able to be turned into different arrays and better understood by the model. The model's actually able to teach itself as more images are sent through it, and basically the higher the larger data set that you have, the model's able to constantly improve itself and get better at producing this output of benign or malignant.
So I'll put you on the spot right now. So Antonio is one of our top students. He is one of the leading students. We can only pick 4 from the university that apply for the Goldwater Scholarship, and that's the most prestigious STEM scholarship in the nation, so he's applying for that. He has a great chance of winning that this year. But also one of the hallmarks is bringing together major companies, right? This is a relatively smaller startup company, and clinicians to solve major problems. So this is not a backyard issue problem, garage problem, right? This is a problem that doctors have had. It's a real solution, but you're not going to replace radiologists, correct?
Correct.
Okay, so this is a tool that allows them to pinpoint things they may miss in this scan, right?
Yeah.
Because right now they miss a lot.
Mm-hmm.
Okay.
So it's meant to basically, as an early pre-diagnostic tool. It's going to help radiologists not effectively make that diagnosis of benign or malignant, but as a pre-diagnostic tool to better help people get the treatment if they need it earlier.
All right, well, Antonio, thank you so much. And the last thing I'll say, I'll embarrass him a little bit. He won a college-wide competition on this project, and that was in front of all our alumni council, a number of different constituents, and we're very proud of them. Thank you, Antonio. Appreciate you being here.
Thank you.
So next, Dr. Staley, why don't you come up, and we have next few students. So thank you, everyone.
Great, so we're going to shift over. Oh goodness, I'm caught here. We're going to shift over to be able to introduce you to a couple more students to talk about their work that they've done. So AJ, I believe you are first up. So AJ, if you will talk to us a little bit about your bone marrow lesion project. So this is an interesting project that we've had going on for several years in the department now, and it's had a lot of breakthroughs as we move through here. I'll let you explain the problem a little bit.
Yeah, so actually 25% of the US population is affected by osteoarthritis, and this osteoarthritis can lead to what are known as bone marrow lesions, which is the main problem that we're dealing with. So right now we're working with actually an orthopedic surgeon at the local hospital at Virtua to come up with a solution to, as you can see on this slide right here, take these MRI scans and then quantify the volume in the bone marrow lesion, because the problem right now is that in order to treat bone marrow lesions, which are essentially degraded bone in various parts of your body, the surgeon will go in and inject this calcium phosphate, essentially bone cement, into the bone. And the problem with that is it's generally effective, but what happens is this underfilling or overfilling, and that's due to the lack of direction that a surgeon has. Surgeons right now, they just go in with the injection, and then the only feedback that they get is this pressure feedback that tells them, okay, maybe this is enough, maybe I have to put some more. So overfilling and underfilling leads to various other problems like pain and further progression of osteoarthritis. So our project really gets in there to help give the physicians an estimate of how much to inject into the patient and effectively give better patient outcomes.
So AJ, this seems like it should be a relatively straightforward problem. You have a hole in the bone and you have to fill it with a certain amount of material. What makes this problem so challenging that it requires engineering teams to solve?
Yeah, so actually what we're trying to do, trying to estimate and use image analysis to figure out the volume in this bone, this has actually never been done before. Obviously, a lot of technology has been there for maybe brain tumors or other kinds of tumors, but volumizing those. But specifically with bone marrow lesions, that technology isn't there right now. So what we're trying to do is work directly with the best of the best surgeons who are very well versed in these procedures to help out future surgeons, future medical staff who might not have that experience to make it easier on them and eventually help patients in the long run.
So there are really two sides to what you're talking about here then, right? There's the idea of how much do I have to put in, and when I'm actually putting it into the patient, how do I know that I have that right amount? And so I need to be able to trust your estimate in terms of that cavity volume and be able to put that right amount in there. How are they doing it now?
Yeah, so right now, the current technology, like I said before, is just to inject the cement and then just feel for kind of feedback pressure that they can kind of tell. Essentially, like if you're trying to fill a jug with water and you could feel that, okay, the jug isn't taking any more water, like you're feeling this pressure back. That's essentially what the physicians are working with right now, which is, if the physician has experience, and they're used to filling hundreds and thousands of bone marrow lesions, they generally are effective. But when you have a new physician who maybe has only worked with this procedure maybe 5 or a couple of times, or for the first time, to have this kind of technology that we're working on to offer to physicians, is just going to help better these solutions, better these patient outcomes in the long run.
Great. I have one more quick question for you. So I know you're bound for medical school. You intend to become a physician engineer. Can you speak a little bit in terms of how you learned about this problem and how that's influenced your decision to go to medical school?
With the project?
This particular project, yes.
Yeah, so actually as a pre-med BME, I've been able to have a lot of experiences here at Rowan, especially in the BME program, where a lot of the faculty have that direct experience with working in medical admissions. So, you really get that hands-on experience. And specifically with this problem right here, with bone marrow lesions, this project was able to give me that tie-in, that collaboration and interface with a physician as an engineer, giving me that experience to see, okay, this is the engineering side, but also working directly with the healthcare team, not just in a lab, but directly, working in conference calls just to come up with a solution to help the patients overall.
Great. Well, AJ, we look forward to you being an innovator in healthcare for many years to come. So thank you for being with us today.
Thank you.
Our next one, our last one to talk about clinic project in this particular format is Dana. So Dana, thank you for coming in to join us today. Can you tell us a little bit about your project?
Yeah, definitely. So my project is working on a drug delivery system that can, a solution will start as a liquid and transition into a gel once injected into the body. And this will help localize some drugs into the particular area that we want to treat. And this need came to us at Rowan from our collaborators at the University of Pennsylvania. And what they want to do, or at least the need that they brought to us, was that cancer patients, often their cancer will sadly migrate to the spinal area. This is obviously a very painful process, and in addition, they will obviously have to have this tumor section removed from their spine. Often, in addition, they'll have to have their vertebrae removed as well, and a titanium cage will be replaced in this area. Yes, exactly. Yeah. It's very painful, and the issue here is that with normal tumor removers, surgeons will go in and they'll remove the healthy tissue around the area as well, just to make sure they get all of it. But working with the spine is a very risky process, so you can't necessarily get all of that healthy tissue around it as well. So these patients will have to additionally go through chemotherapy on top of the surgery, which also delays the healing process. So what we want to do is localize the chemotherapy to that specific area by injecting it into the titanium cage. Yeah, so that's about a summary of what we're trying to do.
Great. So that seems like a very complicated project. Lots of different areas and different facets to that. Is there a particular area within that major realm that you've been working on, that your specific work is focused on?
Yeah, so there's two components to this delivery system. One is a gel that degrades the solution that transitions into a gel and will degrade over time in the body. But then inside of this gel, we have these liposomes, which hold the actual drugs that will be helping the patients. So this is a slice through the middle of a liposome, but you can imagine if there's two of these, we have this little area in the middle that will encapsulate these drugs. And once they're exposed to the body, and they will open up, and these drugs will then be able to migrate out of this and help affect the cells in the area.
Great, and you've been working on this now for about a year, right? So
yeah,
about
a year and a half.
A year and a half. So you've come a long way. Is there any part of it that you feel has surprised you in terms of the engineering applications that you've had to apply in order to solve the problem, or work towards a solution, I should say?
Yeah, definitely. We've with all research, we've definitely hit bumps in the road that really make us have to sit back in our engineering mindsets and work through them. Particularly with the gels, we need to do a lot of work making sure that they will degrade at the right times, that they will gel at the right times, things like that. Really making sure that our solution will gel right at body temperature, 37 degrees, is a huge engineering challenge.
That's fantastic. Well, Dana, thank you so much for coming in to join us to talk about your work. It's some really exciting work, and hopefully can save a lot of people a lot of pain someday. save them from the pain, rather.
Yeah, thanks for having
But
me.
yeah, thanks for coming in. Again, I want to invite everybody to be able to submit questions to the chat, to be able to ask of our students. And I believe it's time for us to open up our panel.
It is. So please chat your questions, and we have a whole student panel here to answer them with you, and obviously we're here as well to answer questions. So should we go to the panel?
Yeah.
Great, thanks.
Should we introduce our panel, or should we allow them to
why don't you
introduce
introduce?
themselves?
Why don't you introduce?
So we'll start with a couple of our seniors that we have here with us today. So Augie is one of our seniors working on medical physics applications in quantum dot biology. He can talk to you a lot more about it than I can. But is a senior in our program and has some extensive experience that he can talk about in the ways that he has navigated his journey here. And Nick is our current president of our BMES student chapter. So we have a very active student chapter of the National Biomedical Engineering Society, which is the major professional society for biomedical engineering. And is one of our seniors, and another one of our seniors who can talk to you about his experiences here in the program. Would you want me to continue?
Sure, please.
The other side of our panel, we have everybody adequately distanced here, so they're across the room when I'm looking at them here. But we have Katie Driscoll. Katie is a Goldwater Scholar. We talked about some of the prestigious opportunities that we have here, that our students have won major awards. And Katie is a junior in our program and a Goldwater Scholar from Colorado, who's doing a really interesting combination of research and outreach type of and social justice type of activities. And I hope you can talk about how you're integrating all of those in your efforts across campus. And we have Lauren Repman. Lauren is an admissions ambassador, so she knows the full spiel in terms of how we market our university from the student side as well. Lauren does research in my laboratory, so I know exactly what Lauren does, but I want to let her talk about it a little bit as well. Lauren is a junior in our program as well. So.
All right, well, thank you, Dr. Staley. So let's ask some questions. The first question we had was on the curriculum. We heard depth and breadth. And so what I'm reading into the question is, can you describe sort of that concentration area that you're in, and how beneficial has it been for you to get that, that depth in the field? So can one of you answer that over there?
I can answer that. Okay, so yeah, depth and breadth. Well, I chose medical physics, so I had a very good meeting with Dr. Staley my freshman year. I volunteered in her lab, and I didn't see where I was going in the future, so I kind of volunteered around with a couple professionals, and I ended up thinking medical physics. Now, Rowan, not many programs has a medical physics program. It's a very small field, so we actually were able to design my degree to focus on medical physics. So I took a lot of radiation courses, controlled release courses, drug delivery courses, and also in our junior year, I know they changed the curriculum now, but we take foundations in mechanical engineering, electrical engineering, like bioengineering, and that extends from, you'll be analyzing trusses that will bridge trusses that will develop into bones, all your bios, all your chems, all your physics, but you also have the chance to hone in on what you actually want to do, which is medical physics for me, and I was able to make my own path here in the department. So.
All right, thanks, Augie. So we have another question, if no one wants to answer anything further on that. We have another question on the 3+4 program, if we can talk about that. So maybe if we get more specific, Lucinda, I'll ask you to come back up. But our 3+4 program, we have a 2. So the BS degree in biomedical engineering occurs in 3 years, and then students seamlessly enter medical school in their 4th year. And then there's 4 years of medical school, hence 3+4. We have the program set up for the BS MD or allopathic MD degree and the BS DO or osteopathic medicine degree. We have 2 medical schools at Rowan, one of a very few institutions in the country that have 2 medical schools, and we leverage both of them for those degree paths. So the students, we have a specialized curriculum for these students, and as Lucinda said, some come in with various credits, but some come in with more and some come in with less. And we designed each part of the curriculum to allow that student to have success. So it's somewhat individualized for each student. Dr. Staley, if you'd like to maybe say a few things.
Yeah, so we have a number of students in both of those programs that are headed towards medical school, and those seats are reserved for the students, but they are not guaranteed. So the students do have to perform and complete all of the requirements of any medical student, which we feel is actually very important because it puts the students on equal footing when they reach medical school as well. So the seats are theirs to lose, so to say, but it's a great coupling between these two programs. We're able to introduce the students to the medical school environments earlier and to get them involved with those programs. And we're excited to see how our students progress. As a new program, we don't have any graduates from the 3+4 all the way through program as of yet. We started in 2014, so we're looking forward to some of our first graduates moving through that program.
Yeah, and what I'll say is, students have to do just as well as they need to transition to medical school. So they don't have the pressure of competing for 100 spots where there's 9,000 applicants. They're guaranteed a spot. So they take the MCAT. That may be the next question. They have to do well in their classes, right? And there's certain benchmarks that we have, but our students have done incredibly well, and all of our students have transitioned very well in that program. Additional questions on that usually involve is there time for internships? Is there time for summer experiences? We've built those into those programs. There is one summer that students can actually take and get an internship that's not filled with coursework. If a student has more credit, they can actually have another summer that they can use. So it depends on what they come in with. But if they come in with nothing in terms of advanced credit, they actually have one summer that they can intern for a major company, et cetera. And so why is that? We want students to be good physician engineers. Their engineering training will help them tremendously in medical school, and we have a lot of data and a lot of colleagues that have gone through that process that back those arguments up. Questions, other questions? Yes, so let me, okay, so we have a question on, when you got to Rowan, and I'll ask this side of the room, so when you got to Rowan, was it difficult for you to make the transition into our core courses? There's a lot of basic science that you need to take at Rowan. So the question really revolved around, like, when do I get into BME related content classes? So if you could comment on that, I'd appreciate it.
Sure, okay. Hi again, my name is Lauren. So when you come into Rowan BME, you usually start taking your first BME class, I believe with the new curriculum, it's the first semester of sophomore year. Okay, but before you do that, not everyone comes in with the same engineering level of knowledge. So we have the special engineering clinic program. So you come in for your freshman year, you're gonna start off with freshman engineering clinic 1, and that's gonna introduce you to all of the engineering concepts that you're gonna need to know going forward. And there's something really special too about our program for the entire College of Engineering. We have a special thing called the Engineering Learning Community. So this is a living and a learning community that you can enter when you come in as a freshman. And usually the students wind up living together in Holly Point Commons, which is our new residence hall. And they take the same clinic classes together. I believe they take calculus together. And then it's really just a great environment for them to get to know Rowan and become accustomed to the engineering life. So I did this as a freshman. I remember staying up until 3 in the morning with my friends, trying to figure out our lab reports in the Holly Point Commons common area. So it helps you to not only get accustomed to the engineering, but to also make those friends and connections that you will have throughout your entire experience at Rowan.
So maybe I'll stick to this side of the room as well. So we got a question of how diverse is biomedical engineering? And I'll comment in general, biomedical engineering it has a lot of diversity, but can you highlight what we do in the department and maybe in the college and university to celebrate diversity and inclusion?
Yeah, so biomedical engineering is a little bit unique in STEM fields and specifically engineering disciplines, in that I think we actually might have a majority female class. And that is a really, really interesting dynamic coming into STEM, because I'm not sure who asked the question, but you hear a lot as a girl going into STEM about how you're kind of going to have to fight a little bit harder for your place. And that's not true at all here. I collaborate regularly with both my female and my male classmates, and that's been super meaningful. And there's a big difference in talking to my friends in other engineering disciplines that don't have the same level of integration and diversity, and they feel a little bit less comfortable in their classes. And sorry, I'm losing my voice. That's really helped a lot of the women that I work with regularly feel really at home in BME.
So maybe I'll also say that, building this department, we value diversity and inclusion. So it's even present on the faculty levels, right? So building the department from scratch, starting with no faculty, we're over 10 faculty now, and it's a pretty diverse faculty, not only where they come from, and also what they've done in their career as well. So with that, there's another question.
Yeah, I think one of the questions we have that I'll address over to this side of the room is, 2020 has been characterized by the pandemic. So what has your experience been here at Rowan in terms of the response to the pandemic? Both in terms of your education and your experience.
Yeah. So I'll take this one. Hi, everyone, real quick. Again, I'm Nick Bellinger. But overall, it was definitely a challenge. I think moving from that in-person to more of a virtual setting. But I think Rowan in general has done it very well. At least for me, I know my standpoint, and with me being the president of BMES, I had also to make my meetings virtual, which was very difficult, and especially just trying to get it out to everybody. But I feel like there's always going to be bumps in the road, but yeah, I mean, we're going to get over, we'll be able to figure them out. We go, we learn. That's the big thing. And professors have always asked for feedback, especially with how going to the virtual settings. How can I make this better? What's working? What's not? And student feedback is the biggest thing that's going to help them. So.
Great. Augie, can you elaborate a little bit about what you're doing this semester? How is school this semester?
Yeah. So, when the pandemic hit end of last year, I actually had a pretty good experience. It was pretty seamless. A lot of my professors, just transitioned to one note on their iPad, just doing notes. But I was actually very impressed because now, since you're a senior, you take a lot of BME specific courses. And I was very impressed how the professors actually adapted to the online environment. It's a lot more. It's not you're taking a test. Let me see your camera on your hands, right? It's you're presenting your knowledge. You're talking in discussions in class, making sure everyone is understanding what's going on, not really performative, as I said before. And I've had the experience, let me see your hands on your test as you're taking it over Zoom. It's really good how adaptive the department has been. So, and even research-wise, I've been able to go in with the protocols. I work in the physics department, and 2 people in the lab, we have schedules, so it really tests people's ability to adapt, and I think we've done very well here. So.
It's great, thank you for those answers. So we also have a question regarding where do our graduates go? So I'll start this and then I'll pivot to all of you so you can highlight where you want to go. So about 60% or more of our students go to industry, the others go to professional school, graduate school and professional school. So I can tell you some of the companies we've had sent students to: Merck, Johnson & Johnson, Dr. Staley, catch up,
we have
Stryker,
Medtronic, Bristol Myers Squibb.
So top companies in the space. And we get that question a lot, do you send your graduates off to places, why don't I go to a school that's been around for 50 or 100 years? Well, in a very short period of time, evidence is out. Our students go to some of the top companies and they have some great positions at those companies. In terms of graduate school, we've sent our students to some of the top graduate schools in the country. So those are biomedical engineering PhD programs. In terms of professional schools, we've sent students to some of the top medical schools in the country as well. And I will note, we have 100% acceptance rate for our students going to medical school, and a pretty high acceptance rate of our students going to graduate school as well. Overall, our job rate for students getting jobs and going out is well in the mid to high 90%. Okay, so it's been exciting to be part of that. In such a short period of time, we've seen great success. So I'll turn it over to this side of the room. Where do you want to go when you're done?
Honestly, I could end up anywhere. I think right now probably as my next step, pursue some sort of advanced degree. So whether that's a PhD or an MD is kind of yet to be determined. But I've been kind of lucky at Rowan in that I've been able to lay the groundwork really well for whatever path that I want to take. So I just kind of have to make that choice. And honestly, I'm not really in a rush about it.
One of the coolest parts about our department is that they offer I believe it's a 4+1 master's program. So this is what my plan is. So right now I'm going to graduate next year, and then I'm going to stay for an extra year to get my master's degree in biomedical engineering, continue my research with Dr. Staley, And then after this, my plan is to go on to medical school, and my dream is to become a dermatologist. So we'll see where that takes me, but I agree with Katie in that the experience here at Rowan has really laid the foundation for my future, and I'm really excited to see where I go.
Well, let's have the other side of the room go on that question as well. Where do you want to go?
I'll be honest, as of like 2 weeks ago, I didn't know where I was actually going. I didn't know whether I was going to go into the industry or if I actually was going to grad school. I kind of sat down with my PI, Dr. Vince Beachley, and trying to just sit down and talk to him about it. And he's like, listen, you love research. It might be better if you go off to grad school first. So that's where I'm now leaning towards. I'm thinking about going for my PhD. I'm going to be applying back here at Rowan. I'm thinking about Stanford, Ohio State, Duke University. But that's the one thing I love about our faculty is you can ask them, like, have a meeting just to sit down if you are unsure about anything. They are willing to, they want to help you. That's the biggest thing here.
Yes, I'll echo that as well. As I said previously, I'm going to graduate school for medical physics, probably a PhD, and we have these, if you have looked at the curriculum, these CCF courses, and like my freshman year, they were a little confusing. I didn't understand what they meant, so I kind of just waited until they came about. So when I had the meeting with Dr. Staley, I realized that I can actually design your own track. So we have pharmaceutical track, orthopedic engineering track, I think there's another one, but you can also design your own track. So I was able to make, I think, a fairly competitive package for a medical physics program, and I'm very excited about it. Again, talking about the depth and breadth, can't say the word, you can hone in on what you really want to do. So if you're applying to a specific biomedical engineering program, whether it be graduate school, it's not just your classic biomedical engineering program. It's you really get all the skills and you get to hone in on one thing you might specifically want to do in graduate school, and it makes you very competitive for those applications.
Great, thank you. I'd like to talk a little bit about what we do outside of the classroom. So we've had a lot of talk about our time as, in discipline and BME. Can you talk a little bit about what you're doing extracurricularly for what you're doing on campus or off campus to kind of, let's talk about that as we do it. So could you start with us for that, Lauren, and then we'll move to Katie?
So when I'm not studying or doing BME work, I'm involved in quite a few activities outside of the classroom. The closest one to my heart is the 3D printing club. So I founded this club just this past month, and already it's been a huge success. So through this club, you can 3D print whatever you want and whenever you want, and it really gives students the opportunity to learn 3D printing outside of the classroom and on their own time. So if this is something that interests you, or if you're interested in starting a club, you can ask me about any questions that you have. I am also the activities chair of the Women in Engineering Club, and that's really cool to be able to say thank you to women for their contributions to the STEM field and to really support them and what they can do for us. On top of that, I am an ELC mentor, so we talked a little bit about that earlier. The ELC is the Engineering Learning Community, so this is where you can go if you want to live and take classes with the same engineering students for your freshman year to give you that adjustment to college life as an engineer. So if you have more questions about that, you can also ask me. And then finally, like Dr. Staley mentioned, I am a tour guide for Rowan, so I have a whole bunch of information about housing, roommates, meal plans, what you can do for fun here, so you can also ask me questions about that.
Katie, would you like to follow up?
Yeah. So like Lauren, when I'm not studying or in the lab, which takes up a good amount of your time, I'll be honest, I am the assistant resident director at the Rowan Boulevard Apartments, so I work in like res life. And if you have any questions about like on-campus employment, you can definitely ask me about that, because that's been a really big highlight of my time here, to get some like actual work experience. The next thing that I do that, like Lauren said, like is closest to my heart, I think that's a good phrase. I'm the president of Rowan Food Recovery Network, and basically our aim is to reduce food waste while helping some of the food insecurity issues around campus. So for those of you who don't know anything about the food system, which I think is like the majority of people, globally we waste anywhere from 1/3 to 1/2 of the food that's produced. And that's a really big shame when there's still people who are hungry, especially now with the increased economic hardship of COVID. So we work on taking food waste from Rowan's campus that is kindly donated to us by Gourmet Dining, which supplies the meals. And we redistribute that to local shelters around campus for people in need. So that takes up a lot of my time, but I really wouldn't want to put that time anywhere else because it's super meaningful.
Great. We'll pose the same question to the gentleman as well. Can you talk about a little bit about your extracurricular activities and what you do around campus as well?
Yeah, I'll start. Yeah, so I was a first-gen student coming in, and I, of course, wanted to join any club that had to do with biomedical engineering, so I joined the BMES Society, our club here, student chapter, and throughout the years, I was able to get on the e-board. I was industrial liaison, currently industrial liaison, and vice president, and what we do, we've kind of especially designed it this year since it's online format, and we try to show our undergraduate students or underclassmen what you can do with your degree, whether that be industry, research, because I know a lot of people, biomedical engineering is great because you can go into a lot of areas, but it's also, it's a little daunting when there's so many areas for you to choose. So yeah, we try to do that as best we can. I'm also part of the club lacrosse team, men's club lacrosse team. So if anybody has any questions, I know we've graduated a lot of actual, I know it's a club sport, but I know we've actually graduated like swimmers, soccer players, like actual like D3 sports athletes. But yeah, there's a lot of clubs you can join as well. And yeah, mainly, I mean, besides that, out of the lab, I like to cook, read. Like, you do have free time, so there's time to do other things. Take it away, Nick.
All right, so just like Augie, I'm a first-gen student, and the biggest thing my mom put on me as I came in here as a freshman was get involved. So instantly I was like looking for clubs, and I saw BMES, so joined that. They had actually a nice mentorship program my freshman year where I got to go, and my mentor was the vice president, Nick Mann, at the time. He graduated, I believe, 2 years ago. From that, I went and became our vice president as a freshman, which was actually pretty awesome. And I've been on the e-board since then, so I've always been part of BMES, and I've been always working to plan a bunch of our events, such as like our fall picnic BMES games. I've planned resume workshops. I've created a couple info sessions, and the big thing, at least this was like Woggy said this semester, our underclassmen, I want them to get to know the professors. I want them to understand what they can do with this. So big things were like meet all the professors. I did that over like 2 meetings. And yeah, I had a couple of industry professionals come in as well. And other than that, I mean, outside of Rowan, I coach football over at Kingsway High School, right down 322, and that's about it.
So we're almost wrapping up, but can you highlight your class experience? How big are your classes? Do you feel like that you can get the attention of a professor in class? How accessible are our faculty? So why don't you take it over here?
Yeah, so I think within the biomedical engineering department specifically, this department really excels in one-to-one mentorship for students. Honestly, since day one, I emailed Dr. Bird my freshman year to get involved in research. And how many other colleges can you email the head of your department and get a response immediately and have him be able to say, here's a lab you can join. So that has been really, really significant. In terms of professors in other departments and classes in other departments, Rowan does have really small class sizes, especially compared to other universities of the same size. So that has been really awesome because I've met some of my favorite professors through my core foundation classes in other departments. And it's really interesting too, as you get to your junior year, I guess sophomore year in the new curriculum, when you start taking classes with just BME students, you get really close with your class. And you get to know people through the 4 years that you're here. And honestly, some of my best friends are other biomedical engineers. And I wouldn't have that any other way because they're all so cool and they're all so different. And it's super interesting to learn about their different interests and what they're doing on campus.
Great, thanks. How about that side of the room?
Yeah, I can touch on that. Yes, the class sizes, as Katie was saying, once you get into the foundation courses, the class is, that classroom is your biomedical engineering class. So whether it be 40 people, we all sit in this one lecture hall, you know everybody. So it's really interesting, that type of dynamic. There's always a group meet and everyone knows each other. So it's really good. And I know the professors might not like it that much, but at Rowan, our hallways are all glass. So the professors, if they're there, you can always knock on the door and maybe they don't want to open the door, but once you press them, they kind of have to, right? So they're always around, and all of them are always welcoming. You can always, as Katie was saying, email the head of the department. You can have a meeting with them within a week, and that's not really something you can do anywhere else. So.
All right. Well, you know what? We're closing today. I certainly appreciate all of you being here today. we're going to close with a few statements, and I'll tell you, one of the benefits of Rowan Biomedical Engineering is you get these smaller class sizes, the individualized experience, but you also get the major impact from a research university, which means we have cutting edge projects, cutting edge collaborators, right, that are in the field, they're working on things that no one else is working on. And you get the benefit of both. And that's really one of the strong points of the educational experience here. So with that, Dr. Staley, if you'd like to sign off, we can sign off. And
well, we thank you for coming, and we do invite you to follow us on some of our social media platforms. We have an Instagram page, Rowan Biomedical Engineering. We also have just started a Twitter account as well, so I believe that's Biomedical Rowan, at Biomedical Rowan, that has our Twitter feed. We invite you to follow us on our social media platforms there. Feel free to ask us any questions. You can always email in the department at bme@rowan.edu. So those emails will come into the department and be funneled into the correct person to be able to answer them. We can also forward any questions that you may have for our panelists and student presenters today. All of them have agreed to be able to answer questions outside of this platform as well. So thank you for coming, and we hope to see you as a future prof here in Rowan BME.
Great, thank you. And don't be afraid to reach out. So we're here for you. This is an important decision, and you know, we want the best and brightest at Rowan, and hopefully you can see, hopefully you saw today that we do have some of the best and brightest here. So thank you very much. Thank you for joining us. I thank the students once again for being here. Your contributions are very important. Thank you. Thank to Dan and Sean and admissions for setting all this up, and certainly the crew. So thank you, everyone. Have a great day.